Alrighty. Good morning, everybody, and welcome to the wolfSSL Live Partner Webinar with StrongSwan, with wolfSSL Senior Engineer Eric Blankenhorn and StrongSwan founder Andreas Steffen. My name is Kajal Subkota, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box. Or raise your hand to be unmuted if you'd like to ask the question live, as we do host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel. I invite you to follow us on Twitter at wolfSSL, as well as all of our other socials. Also, please feel free to email us using facts@wolfSSL.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual licensed embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This progress is, of course, supported by a strong partner network that we're very proud of, which includes ISRG, STMicro, and Curl, for example. Since the beginning, our engineering team has developed several embedded products, including wolfCrypt with DO178 support, FIPS certification and a FIPS-ready offering, MQTT up to the version 5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, and embedded IDPS known as wolfSentry, as well as Java wrappers and JSSC support, and commercial support for curl. All of these offerings are accompanied by thorough maintenance support plans up to the 24/7 level. We also offer full service consulting. And now I'm going to hand it over to Andreas for the technical presentation.
Okay. Okay, so my name is Andreas Steffen. I'm the founder of the StrongSwan VPN project, and I want first to give you a short overview on the history of StrongSwan and of its capabilities. In 1999, when I left industry as a communication specialist and became a university professor, I started to contribute to the FreeSwan open source IPsec project, which was founded by John Gilmore, and who financed a team of about 4 or 5 developers in Canada, just outside the US, because at that time there was still an embargo on the export of strong cryptography. And together with my students, I contributed the X509 patch to the FreeSwan code, which implemented strong authentication based on X509 certificates. Later on, we also added support, smart card support using PKCS 11. And all these patches, which never were integrated into FreeSwan itself, they were bundled by Ken Benpoft, I think, into Super FreeSwan, together with some other patches. And Super FreeSwan was very popular at the time on Linux operating systems. FreeSwan had an IPsec stack of its own in the kernel, which was called Clips, which was quite tiresome to build with a lot of kernel panics. And we were very happy when with Linux 2.6, the Netkey IPsec stack was introduced, which is part of NetFilter. And then FreeSwan was ported to the Linux 2.6 kernel using the built-in IPsec stack. And of course, I also ported the X509 patch, which was quite a lot of work. Then in 2004, John Gilmore discontinued the FreeSwan project because he thought that everything had been implemented. And after some discussion with the OpenSwan project, where some of the developers, which was founded by some of the development team, FreeSwan development team, I just decided to do a fork of my own. And based on the same code basis as OpenSwan, I started to distribute the StrongSwan 2 version. Then in 2005, IKE version 2, the Internet Key Exchange Protocol, which is an auxiliary protocol, which is needed to authenticate peers and set up an IPsec connection. The new second generation RFC was published, and 2 of my students approached me and asked me if they could implement IKE v2 as part of the diploma thesis. And I told them, you are crazy, but they did it anyway, and they were quite successful. And this was at the University of Applied Sciences in Rapperswil, Switzerland, where I was a professor. And this IKE v2 daemon was based on a totally new object-oriented architecture. A prerequisite was it being written in the C language, and it had to use the same FreeSwan configuration syntax. Then we bundled the new IKE v2 daemon together with the FreeSwan IKE v1 daemon as a kind of a screen level integration. And we were the first open source distribution on Linux which had a full IKE v2 implementation. OpenSwan also partially implemented IKE v2, and later on, when there was a fork from OpenSwan to LibreSwan, Paul Wouters finished IKE v2, so LibreSwan now has also full IKE v2 support. And then in 2012, we were asked by a customer if we could implement IKE version 1, which was at that time already a legacy protocol, but is still very popular, especially because of the iOS and Android phones, which still used Raccoon. We were asked to implement IKE v1 using our new code base, and then we released StrongSwan 5, which had its 100% object-oriented code and no similarities anymore with FreeSwan or OpenSwan. So there is no shared code anymore. Okay, initially StrongSwan was running on Linux. You could use it as a VPN gateway. And we have some customers who are running more than 64,000 tunnels, concurrent tunnels. Of course, you need an appropriate hardware with enough kernels, so you can support 64,000 kernel. There is also a high availability setup possible with the hot standby gateway. And you can have a connection to a free radius or a Windows Active Directory server, which manages your user credentials. Of course, on the other side, you could also use StrongSwan as a lean Linux client. We offer full integration into the network, into a net manager. But because most people don't use Linux as their desktop operating system, we were very happy when Microsoft published an IKE v2 client with the release of Windows 7, and Microsoft tested that client for about more than 1 year with StrongSwan. So interoperability is very good between the Windows client and StrongSwan. Later on, we ported our code to Android, which was quite a big effort because Android is not Linux. And we also ported it to the Windows operating system itself, using the native Microsoft IPsec stack, also to OS X using the PFK IPsec stack, also to FreeBSD and to iOS. So StrongSwan is available on all major operating systems, and it also offers full IP version 6 support. Okay, something about the StrongSwan daemon. Actually, the Internet Key Exchange protocol is running in user space. And it communicates over a netlink socket with the Linux kernel, with the native IPsec stack, and the Internet Key Exchange Protocol uses UDP datagrams in order to set up a connection. It's the well-known port UDP 500 or 4500. The StrongSwan code is published under a GPL version 2 license, and it is configured by the Swan Control command line tool, which reads the configuration from a swancontrol.conf text file. And this Linux Unix socket for the versatile IC control interface is published under an MIT license. So everyone who wants to use StrongSwan with their own management interface can do that without violating the GPL version 2 license, because the socket interface itself is under MIT. It's also possible to do, we also offer Python, Ruby, and Perl wrappers. So you can write a management interface of your own using Python, Ruby, Perl, or any other language like Golang. It's also possible to do userland IPsec encryption. For example, this is what is done on Android and iOS, where the Android operating system offers a TON device, and then we just do the encryption in user space, because we don't have any access right to the Android or iOS kernel. This was added in 2015. Something about the architecture. StrongSwan is very modular. It's based on plugins. We have the Internet Key Exchange engine, which manages up to several 10,000 security associations, tunnels. So there is some kind of management infrastructure. We also have a socket which receives and sends IKE packets. And in order to support several 10,000 tunnels, the architecture is fully multi-threaded. By default, 16 concurrent worker threads are spawned, but you can increase it to more than 100 threads if you need them. Over the years, more than 140 StrongSwan plugins were added. By default, if you just build the default version, only 35 plugins are built by default. The modularity offers a generic interface for credentials. So private keys can be read from files, from smart cards, from a TPN, from a database. Also configurations can be read from files, from databases, over a dbus or any other interface. Just write the driver for it. There is also a generic bus for doing logging. And there is also a very flexible kernel interface. So in the meantime, you support about 6 different IPsec stacks: the Linux one, PFKey 2, and the Microsoft stack. And then, of course, for crypto, we have plugins. And one of the plugins is the wolfSSL plugin, which was donated to the StrongSwan project, I think about 1 or 2 years ago. So if you want to use StrongSwan with wolfSSL, then you just, in your configuration file, just add wolfSSL plugin to the system configuration, and all crypto will be run with the wolfCrypt library. So I'm giving back to Eric.
Great, thank you, Andreas. So go ahead and pop my screen up. So I'm going to walk you through setting up, configuring wolfSSL, building wolfSSL, and then also configuring and building the StrongSwan project. So I'm Eric Blankenhorn. I'm a software engineer here with wolfSSL. Been here a few years now, and so with that, I'm just going to jump right into the description of wolfSSL's FIPS wolfCrypt object module. So as you see from the diagram here, basically the wolfCrypt FIPS module exists as a subset of all the wolfCrypt algorithms, and it makes it easy and painless to update for new wolfSSL releases. and also maintain an existing wolfCrypt FIPS validation. So most of the vulnerabilities and bugs and stuff like that happen within the SSL or TLS layer. So by creating a wrap around or a sub module for that, you can basically avoid all those issues that might happen outside the FIPS module. So let's jump right in and talk about configuring wolfSSL. So basically all these instructions are available as a blog post. So you can walk along with us, or if you want to go test this out yourself, you'll be welcome to go check out the blog post. So I'm going to start with wolfSSL's commercial FIPS release, version 4.7. That came out around February. We're currently working on a new release, expecting it out in the next month or so. First steps are going to be configuring. We're going to turn on our OpenSSL compatibility layer. So that's basically the glue that allows StrongSwan's already set up code to operate with wolfSSL without any API changes. We're also going to turn on certificate generation support, session support, OCSP. We're going to set up all the algorithms that we wish to support. And we're going to turn on the assembler speedups as well. So then we're going to do a make check, and then we're going to install to a specific directory, and that directory is going to be used when we configure our StrongSwan build also. When we set up StrongSwan, we're just going to grab the latest. We're going to do a configuration as Andreas had shown. We're going to have to turn on wolfSSL support. We're going to disable the default options. We're going to turn on PKI support and PEM support. We're going to do a make check, and we're going to install this special directory here. So I'll go ahead and load up my VM real quick and get that shared. So from here, I've already gone out and cloned those two projects, or downloaded the commercial version of wolfSSL's FIPS. So I'm going to go change into there real quick. I'm going to start by doing that configuration we talked about. And so pop that in there. And as you can see, it's going through and setting up the environment and setting up for the options that we chose. So the one thing that's interesting about the FIPS layer is the FIPS has what's called a power on self test. That basically allows the validation of the integrity of the wolfCrypt FIPS module before anything else gets to run or any of the functions within there get to be called. And that's all kind of described out. If you want to look at more into that, you can check out our FIPS landing page on our website. So you can see over here, this is all the code that was, this is basically the plugin layer within StrongSwan for wolfSSL. And so you can see they've got support for all the various algorithms and signature algorithms that are supported within the wolfSSL. So in addition to all the just the porting that was done, there's also been quite a bit of test additions that have been done around the StrongSwan integration. So our make was clean. We're going to do a quick make install. And so now we're done with our wolfCrypt FIPS library build. So now we're going to back out and go into our StrongSwan folder. So from here, we're going to do that configuration of StrongSwan that we talked about. So that's going to involve setting up that enable wolfSSL. And that's going to just tell StrongSwan that we're going to use the wolfSSL crypto library. So there were a couple challenges, not challenges, but there were some interesting things that came out of the original porting effort. When we were doing our tests, there were basically a couple of tests within StrongSwan in the make check that actually started failing after we enabled the FIPS code. And so after a little bit of digging, we determined that one of the thing that was failing was that one of the tests was for a key size that was not supported within wolfCrypt FIPS. And so it was failing exactly as you expect it to, because that key size was not part of the validated wolfCrypt FIPS module. That test has since been removed from the check suite, but it was just a good indicator of what happens when you're using FIPS, and things that you would expect to see fail or definitely do fail. So we got a couple of warnings in there. Those are all basically redefinitions of parts within like the ASM parser that are defined in both wolfSSL and in the StrongSwan project. So nothing too concerning there. All right, so we got a clean make. So now we're going to go make check. And we'll watch all these tests run. And again, these are all tests that are running within StrongSwan. And these tests are, StrongSwan's utilizing the wolfSSL's wolfCrypt FIPS module at this point. And so this would basically be a FIPS validated application at this point that you could take through certification. Or if you're using one of our already certified operating environments, then you could go straight to market with it. There we go, all passed. So that was setting up and configuring and building wolfSSL's wolfCrypt FIPS with StrongSwan. And let's swap back over to our main presentation. There. So at this point, I think Andreas has some interesting bits he'd like to share with us, another demo that he set up.
Okay. Now that Eric has compiled both the wolfSSL FIPS library and StrongSwan itself, I'm going to show you actually a demo setting up an IPsec tunnel using StrongSwan. Just switching to my screen. And which one is it? This one, I think. Okay. And what you see here is our KVM-based virtual test environment, which is consisting of 9 virtual hosts. And using this network topology, we can simulate all imaginable test use cases like site-to-site VPNs, remote access VPNs, netted VPNs, and several other things. I'm going to show you a remote access scenario where we have a remote access client called Carol, which connects to a VPN gateway Moon and wants to access a network, the 10.1 network, consisting of the two virtual clients, Alice and Venus. Authentication is based on X509 certificates, of course. And there is also a web server running on the Winnetou host, which allows both endpoints to download a certificate revocation list. It would also be possible to run OCSP here. So you would have the online certificate status protocol. In StrongSwan, over the years, we have assembled more than 430 test scenarios, which we are using regularly for our regression testing. So it's very a rare event that a new StrongSwan version breaks after our release, because we find most of the bugs doing regression testing. So I'm just okay, so I have two terminal windows. So I have here client Carol and here host Moon. So I first start the daemon. Daemon is actually a system D service. So I'm starting the StrongSwan daemon, system control, start StrongSwan. And I do the same on the remote access client, system control, start StrongSwan. Then by default, we offer the Swan control command line management tool. So you see Swan control stats gives you some statistics. And here you see all the plugins which are loaded. So you see here you have wolfSSL. Externally, we only need PEM for PEM format. And for parsing certificates, we use PKCS1 and our X509 ASN1 parser. But all crypto is contained within the wolfSSL plugin. Also during the startup, the certificates have been loaded. So Swan control list certs shows you the certificates. So we have Carol's end entity certificate, and we have the root certificate. Now there's also a connection definition. It's Swan control list cons, shows all the connections. So we see it's based on IKE version 2. We want to connect a host under this IPv4 address. And this is our own identity, this is our own certificate. And actually, in order to verify that we are connected with the correct host, we want to connect with moon.strongswan.org. And the network behind the gateway is 10.1/16. Now we set up the IPsec tunnel using the IKE protocol. So it's Swan control, initiate, child, home. So now it's up. Now we can see that the tunnel is up. Swan control list security associations. So we see now that there is a connection between Carol and Moon with the corresponding IP addresses. This is the cipher suite which has been selected. So it's AES 128 bits. It's SHA-256 as HMAC and SHA-256 as the pseudo-Redner function. And Diffie-Hellman exchange was based on elliptic curve group 256 with a 256 prime number. And we also have here the child assay, which is actually the encryption of the IPsec packets of the payload. which is done by the kernel. So this is done by the kernel interface. By the Linux application, we are using AES-GCM in the kernel. And now we can ping one of the hosts, just one ping to Alice. And we have one ping to Venus. And now we see, if you can see that we have now, this is the statistics of the IPsec interface. We have now sent 2 packets over the IPsec tunnel, because of course use Wireshark to verify that it says freely that payloads are encrypted. You just believe me that it's been done. And also there is another swan control command, swan control list algorithms. So you see with the FIPS implementation, you have AES, you have SSS, you have SHA-2, SHA-2, SHA-3, and you have the hash functions. You also have the Diffie-Hellman groups, the elliptic curves one, the traditional prime number-based ones, and also the random generator is actually implemented by wolfSSL. Okay, this is my demo, so I'm giving back to Eric.
Fantastic. That was excellent, Andreas. Thank you. So I take back the screen control real quick. And so now we're going to talk about a couple of things that we're looking forward to. So definitely more webinar demos. There's lots of things we can show you as far as integration between the two projects. StrongSwan's shown some interest in setting up support for our Wolf TPM driver that would allow basically key storage or key generation in a trusted hardware environment. More testing is always great, helps everybody, and it shows just what a great product we have on both sides. So then also there's been some interest in supporting using wolfSSL's PKCS12 native support within StrongSwan. And outside of that, we would love to hear from the audience and the general public to see what you would like for us to demo for you and to show you and teach you. So definitely reach out to us. And with that, I think we're going to start turning this over to questions from the audience. So Kajal, have we gotten any other questions up yet?
Yeah, we have, I think, do you see it? It's about some notes I think you'd like clarified or confirmed.
For sure. So looks like Tobias is one of the maintainers over at the StrongSwan project. And so he has some notes for us about the example. And so one of those is that the disable defaults isn't really, it's basically going to turn off all the, you don't have to do that because it turns off everything. It doesn't need to be, you could do that manually. And then also another note was to use the test vectors. And so that's going to help out by actually exercising all the underlying algorithm support. And the last one was that maybe we should try without OpenSSL, because all of those, that wolfSSL plugin contains actually all of the API interfaces natively. So we're going to test that out, Tobias. Thanks.
No, I didn't need OpenSSL. I just need a PKS1 in order to actually extract the public key from the certificate. But I think it could be done by wolfSSL. I just have to have a look at it, just extend the wolfSSL plugin. So there would be no external plugins be required except the X509 certificate parser, I think, which is not supported by the current wolfSSL plugin.
Okay, excellent. thanks for those notes, Andreas.
Awesome. We have a couple of questions here. When does the wolfSSL FIPS certification expire?
Okay, yeah, I'll take that one real quick. So our certificate number 2425 was one of our original certificates, certifications through NIST, and that's actually set up to sunset, I believe this month. I don't know if that's been extended or not, but we've got a clear path for customers to start using our 3389 certificate. And we also have in our plans to go ahead and get our 140-3 certification out. It's pending right now through NIST. So yeah, we've got a clear path forward for customers to continue using wolfCrypt FIPS certified module.
Awesome. Okay, we have a question from Marcus here. What is latency, for example, ping for demo? And what is underlying H/W for demo? And is StrongSwan supported on Raspberry Pi?
So Andreas, can you speak to the hardware you're using?
For the demo, oh, it just was on a, I think it's a Lenovo ThinkPad, which I was using for the demo, with running KVM on it, so in a virtual, on a VM. I have been running StrongSwan on the Raspberry Pi for starting with, I think, with the first generation of the Raspberry Pi, even doing at the station on the Raspberry Pi, using a piggyback TPM, so there is no problem. Of course, it's rather slower on the Raspberry Pi, especially the earlier generations. For latency, well, it depends really on the hardware. And of course, the IPsec encryption adds some latency to it, but I think it should be negligible. Tobias might have some additional information. So it's running on rather very weak platforms, and it can also be run on very powerful platforms with more than 24 cores. We had some special hardware with 40 cores where StrongSwan was running. So performance depends, of course, on the hardware. And of course, the encryption, the IPsec encryption is done by the Linux kernel, and which needs some special setup in order to use all the available cores, splitting up IPsec encryption. IKE itself, of course, also can use multiple cores, so each essay can be assigned to another processor core. And 80% of the computing time with the IKE protocol is spent in the Diffie-Hellman key exchange. So it's usually the most computationally expensive thing. And of course, also certificate-based authentication. So it's actually big numbers, which are very expensive.
Awesome. And we have a hand raise from Edward Klein. I'm going to allow him to talk and ask his question live. Awesome, Edward, you're good to go.
You hear me?
Good morning.
Yeah, sorry, I hit that by mistake.
Oh, okay.
I was going to answer the Raspberry Pi question because I use it all the time.
Oh, okay.
I think, yeah, they specifically want to know if StrongSwan is supported on Raspberry Pi, or if they can use it on Raspberry Pi.
That's no problem. It's just it's on the Raspbian operating system. There's no. It's just a normal setup.
So just curious, Have you tested with wolfSSL crypto on Raspberry Pi also?
Not yet.
Okay, well, that's something else we should try out, and
Okay.
and maybe that'll be our next demo.
No,
So yeah.
yeah, no, just I've been using OpenSSL plugin for elliptic curve cryptography, but not the wolfSSL yet. But it might be worth a try, yes.
Yeah.
Okay, fantastic. We have another question right here, which is, can you add FIPS certification for other algorithms?
Yes, absolutely. So that's something that we do all the time for customers doing custom certifications. We also support things like allowing you to rebrand our certification under your company's name. So those are all modifications that we can accommodate. And just suggest you go ahead and contact FACTS, FACTS at wolfSSL.com to get more info.
Alrighty, I think those are the last of our questions. I'd like to thank you, Eric and Andreas, for a fabulous presentation. And just a reminder to everyone, this webinar is recorded and will be made available on our YouTube channel, which is just wolfSSL, in a couple of days. And if you'd like a copy of either the presentation slides or anything, please feel free to email us at facts@wolfSSL.com. And if you have any additional questions, comments, also feel free to email us at facts@wolfSSL.com, and we'd love to help you. Thank you so much.